Welcome to an Azure Incident Retrospective. I'm David Steele.
And I'm Simon Kuba. We both work in the Azure Communications team.
In addition to providing a written post-incident review after major outages on the Azure platform, we also host these retrospective conversations.
You're about to watch a recording of a live stream. We invited impacted customers through Azure Service Health and Azure Service Health Alerts to participate in a live webcast featuring our relevant engineering leaders.
By joining one of our live sessions, customers and partners also had access to a Q&A experience to ask questions of our engineering experts during the event.
As you know, building reliable applications in the cloud is a shared responsibility. So this conversation includes our learnings at Microsoft, as well as guidance for our customers and partners to make their services more resilient.
We hope you enjoy the conversation that follows, and we really welcome feedback on how we can make these sessions even better. So feel free to scan the QR code below the recording for our 2.5 question survey.
Wonderful. Today we're going to be looking at an Azure OpenAI issue. It occurred on the 29th of May. The outage has two parts. Firstly, customers experienced issues which were stemming from issues that we had with OpenAI in Australia East. We thought that we had mitigated, only to have the same issues surface again, this time a lot more broader because of issues and the deployment reaching Sweden Central. And it was at that point that we realized something was awry with the system.
Yeah, anything to do with a reoccurrence or anything that impacts multiple regions is obviously super impactful and something that we want to talk about. So with that in mind, I'd like to introduce a couple of engineering leaders joining on our panel today. On my right-hand side, first up we have Sid Siddhartha. Sid is our Vice President and Engineering Manager. We've also got Nitin Goyal, and Nitin is our Director of Engineering. They're both from our Azure AI platform team. Thank you for being here today to explain kind of what went wrong and then what we learned from it.
Super. Thanks for having us.
Thank you very much. Sid, if I could start with you. Before we get into the incident itself, I always think that Azure OpenAI has this weird relationship with regions, because when I deploy something to a region, it's not necessarily being run in that region. And depending on the controls, depending on inferencing, depending on sovereignty requirements from customers, all of these things can have an impact. Could you walk myself and customers through how the inferencing system works, how routing logic works in Azure OpenAI, because it plays a role here in this outage?
Yeah, absolutely. So, like you rightly pointed out, for the AI systems are evolving pretty fast, and we, in general, live in a capacity-constrained environment. So GPUs are spread all over the world, and the routing plays a central role to ensure reliability for customers, as well as latency for customers. And AI or LLM latency more broadly is a very important experience factor for our customers. We broadly have 3 layers in our routing stack. The first layer is the customer region. This is the region where the customer creates the resources in, and they call the API endpoint in that particular region. This is our auth layer. Then after that, we have the API layer, which continues to be in the same region. Finally, we have the inference load balancer. This is the layer where the routing can go globally. And this is where we take into account GPU utilization, latency factors, redundancy. And this is the layer which also enforces the very important data zone residency requirements that customers have. I know some customers have EU data zone or US data zone, or if you can have maximum flexibility, then global. So that's sort of the layers. And in this particular case, obviously, the inference load balancer was the one that got impacted.
Right, okay, so now we understand some of the pieces involved and how the kind of inference routing works. Mm-hmm. You mentioned at the beginning that we're capacity constrained, right? Mm-hmm. People understand that we'd love to have infinite GPUs, that's not reality. Mm-hmm. So what's supposed to happen when we have capacity pressure? Mm-hmm. That's what I'm looking to understand is, if we have these capacity constraints or they have these transient failures, what's supposed to happen? We talk about retries or back off or load balancing. What should that look like?
Yeah. So in general, our routing stack is it's bread and butter for us to ensure that customers' traffic spikes or capacity going down or capacity crunches are gracefully handled. So there are various layers of protection built into the system. First is just the pure routing mechanics. So for example, let's say if your data zone traffic increases because let's say there's a spike in Europe waking hours, automatically the global traffic will be routed away to the other regions. So that's defense number one. Now, let's say we also have quotas and throttling limits upfront for customers so that no single tenant can overwhelm the system. After that, let's say if we are down in capacity for various reasons, hardware constraints, hardware problems, all those are fact of life. In that particular case, we auto throttle and we also have exponential backup strategies. And the auto throttling is in the priority order of tiers as well as product offers. For example, PTUM, which is a provision throughput offer, is more guaranteed than a pay-go offer, for instance. So just to summarize briefly, we have routing, global routing. Then after that, we have quotas and limits. Then we have graceful degradation based on the product priority. That's roughly our strategies. We have much more sophisticated ones as well, but broadly, this is where we are.
That's fascinating. And I know each of those play a role in this, particularly with the routing. But before we get to this, Nitin, if I could turn my attention to you, the trigger event for this seemed to be a small change in the way an API behaves. And it changed some of the retry logic. Now, it seems like such a small thing to happen, and we missed this thing at first. Could you walk us through what this change was and how it created the conditions for something that ended up being global?
Yeah, definitely. So we have an internal API that is used by some of our large 1P first-party workload at Microsoft only. And they made a change to get some of the error codes that they get from the model to go back as a different error to their clients. Okay. And then they rolled it out. They rolled it out to Australia East first on May 28th, and then later on, after several hours, they rolled it out to Sweden Central. This API change triggered the retry behavior in the upper layers above that. And so because it changed the meaning of certain errors that were coming from a model, which were like essentially the 4 to 9 errors from the model when the model is out of capacity and it's handling more than it could. So those errors previously were not getting retried in the upper layers, and after this change, they started getting retried because of the change how the response code looks like to the upper layers. And that amplified at each layer above that, and ultimately led to several times of each bad error request retried several times to the system.
Yeah, I'd love to stay on this topic a little bit because that retry amplification effect is fascinating. I know when we were talking through the post-incident review, it seemed as if this was, initially it seemed like this could be a traffic spike or there's something extra happening, but based on what you're saying, actually the volume was pretty normal. The volume stayed relatively organic, and it was this retry amplification effect that effectively meant that one single failed request was becoming dozens of retry attempts because of that API change. Have I understood that right?
That's right. Like one failed request was getting retried up to 48 times in this case. And this was one of our 1P workloads. And for one of their models, they were running low on capacity, which was getting ignored before. And after this change, it got surfaced up, but not in a bad way.
Yeah,
sure.
Yeah. So even, if that made that change, but there were no failures, it would have gone undetected. And so the failures happened, but every time we had one, it's like we had 48. But then I go back to what Sid said earlier, and Sid said, listen, we're prepared for things like this. We have tons of throttling, rate limiting, global routing. Did any of those help during this kind of thing as these retry storms were occurring and bubbling up? Did all of Sid's earlier mentions, did they help kind of dissipate any of that impact?
So partly, yes, but not all the way through. So these 1P customers, they use an offer for which we do not have any throttling as such, or we have a very limited throttling mechanism for them, because our throttling is mainly there for protecting the GPU resources, and the CPU resources are supposed to scale out to handle the increase in load. And we have monitoring and perf testing to assess what is our CPU footprint should be. And that's our primary mechanism to scale out those CPU layers. So in this case, because the increase in retry or the retry amplification came from the 1P workload, that was not subject to some of the same throttling mechanism that we have for the third-party facing offers.
That makes sense. Obviously, when it's third-party traffic, we might have to be a little more cautious about it. Some of our 1P users, we trust, we let them kind of chug, and in this case, that bit us a little bit. Now, Nitin, I'd love to understand when the first major impact occurred in Australia East, at one point it appeared as part of our mitigation efforts that disabling an internal feature had resolved the issue, right? I'm really interested in this, what we understood at the time and how that initial kind of misdiagnosis happened. What led the team down that path, and why did it initially seem like that was the correct diagnosis?
Yeah, that's a very fascinating event that happened. Like we had a latent bug in our inference load balancer that was like really a race condition that but the code has been there for many, many months, and this issue didn't trigger, But because of the retry amplification, the increased load made that latent bug to surface up and cause crashes in the system. So when the team first looked at the issue, the first issue, they saw overwhelmingly this kind of crash signature that pointed to this particular feature and this particular latent bug. And so they disabled that feature through a dynamic configuration within minutes so as to mitigate that. And what happened was that, this happened because of the rollout to Australia East for the bad change that I mentioned earlier. And coincidentally, by the time the team disabled the feature, it coincided with the natural, traffic drain period of like Australia East region. And so the models there, the 1P model there were not capacity constrained anymore. The errors stopped coming, so the retry storm also stopped.
Sure, that's a fascinating correlation, doesn't imply causation. Hey, we turned this off and then things started to go well. That wasn't anything to do with what had changed. That's interesting.
Yeah, what's additionally interesting is that the way, Sid, you described how the traffic works. And so typically speaking, if we see failures, if customers have hit global, we'll route that around the world and so on. And so what I'm imagining is, while it was in Australia, there was degradation and so on. And that rollout continued. We saw the red herring. We fixed that kind of latent bug. And as you said, Australia happened to wind down at the same time. But then that deployment hit Sweden. And I know Sweden is a significant place. And if requests were being routed to Sweden before and they were being handled successfully, and now that API deployment has hit Sweden, we don't have a safety net anymore. And so as it hits Sweden and it gets big, well, and this is really where global impact occurred, could we think about how did we observe that in Sweden, and what were the conditions now that made it apparent that this was a Sweden issue in the second wave versus Australia? That signature was different that we saw from the latent bug?
Yeah, that's right. Because like we disabled the latent bug feature, so now that allowed us the real error to occur. Like so, basically we started seeing out-of-memory crashes caused by the retry amplification, and then the team started looking into why the machines were going out of memory, and that led to the investigation. Okay, we see a huge surge in requests for certain models and certain endpoints only.
That's what I'd love to click into, kind of on the day, our incident response. Obviously our detection was pretty good. We had good signal of what was happening. How did you go about investigating the crash symptoms, and how were we ultimately able to identify the retry storm and trace that back to the upstream API change?
Yeah, the first incident happened during the PST nighttime. So it was handled by our offshore team in India. But the second issue, which coincided with the Sweden central rollout, that happened in the PST morning around 7:30 a.m. And that's when me and my team members got paged in.
You were engaged on this outage?
Yes. Yeah. So I was there to investigate the issue and see what's going on and try to mitigate it. And so immediately we saw the out of memory issue, and then we started looking into the reasons for that, and then we looked at our request metrics, and split by overall request metrics were not showing that much of a anomaly, but when we look at the per endpoint, then we were able to split and find, okay, these were only a handful of endpoints that were causing the issue. And then, we were able to move them over to a separate cluster so as to quarantine them and protect the rest of the workload.
That's interesting. So, hey, we figured out it wasn't unique requests. A bunch of these were retries and could take it from there.
That's fascinating. As we pivot towards learning from this incident, one of the things that I found fascinating is the distinction to say first-party workloads are not subject to the same scrutiny as customer workloads. And we've made that distinction, but we're looking to change that. And can you help us understand what have we learned and what protections are we going to apply now to these first-party versus these third-parties workloads?
Yeah, definitely. So as I was saying earlier, that our throttling, most of our throttling mechanisms are there to protect the GPU resources. So first party, they have their own GPUs, so we don't necessarily, they are not subject to the same throttling mechanism that third party customers are who are using, a different offer. But like this incident taught us that, like, for A, we cannot trust the first party, and B, we need to have some sort of separation between different workloads so as to have isolation and reduce the blast radius when in the event of such an outage.
Sure. Yeah, Sid, I'd love to bring you in here. Right? It seems like a major repair item coming out of this is moving some of those large first-party AI workloads onto dedicated infrastructure, right? But what does that separation look like in practice, and how does that help us reduce risk ultimately?
Yeah. So first thing I want to surface is this issue was surfaced by a 1P workload. But the solution is not 1P specific, so sure. I do want to emphasize that. As a strategy point of view, the two painful lessons, right, which we've done in other parts of the stack, but we need to reduce the blast radius, we need to detect early, and we need to have throttling mechanisms irrespective of the kind of workload. So that's what. So that's one thing I do want to emphasize on. And this was in our plans, but we have obviously accelerated it after the incident. So in general, at least for the inference load balancer, because it's such a critical component for global routing, and it going down affects all models. That's why the amplification was so much worse for everyone, not just a single model. So what we'll do is we will have smaller shards, especially in these big regions like Sweden Central, East, US2, because the impact is outsized. So we'll have a lot of stamps where the traffic is sharded by request type, priority, and things like that. And both 1P and 3P will be subject to the same throttling and all those protections that we plan to build.
So can I follow up there? The sharding, I love the idea of creating granular fault isolation. Mm-hmm. I also know that introduces capacity challenges. If it's much easier in a global pool to kind of put some round robin or first come, first serve. Yes. When you create these hard walls between first party, third party, and other sorts of contracts you have, how are you going to navigate those capacity challenges? That's
a great question. So first thing first, right? We do want to reduce the blast radius, even if it means throwing a bit more capacity. That's stage one, right? And I know it's harder given all the capacity constraints we have. But in general, we are following up with a fairly sophisticated sharding scheme that's not static. Okay. So we're going to ensure that we balance utilization as well as isolation. So we have pretty sophisticated schemes like shuffle sharding and a bunch of these industry-leading techniques. So we're not, I do want to emphasize that we'll be smart with sharding. It's not like we're going to have these static partition sets which lead to worse utilization for both our customers and us. Because at the end of the day, it's not enough to just reduce the blast radius. We do need to ensure that our customers get the best latency and the best routing and the best prompt cache mechanics for which their whole application depends on that. So we do want to emphasize that we're going to balance both.
That's great, and I'm glad to hear that it's not a kind of raw, brutal sharding. It's a little bit more sophisticated than that, as you say. I'm interested to understand. Nitin talked us through some of the fog of war during the incident, and one of the repair items looks at how we can help engineers to distinguish between what are secondary symptoms and what was the true source of the overload here. That looking back, what clues were available that might help us to identify that it was this retry amplification scenario, and how do we identify that more quickly in the future?
Yeah. So before I answer that, just want to briefly touch base on what systems we have today. So first of all, we have outage detection systems which fired pretty fast. and we were able to communicate it to customers in an automated way. So that detection we've been working over last 6 months or a year even. So at least detection was very fast in this particular case. And including all the customer resources were identified. The second system that we have is how quickly do we auto triage so that the people who are paged in have all the information possible to mitigate. And in most cases, we do want to auto mitigate without any manual intervention because that's the fastest possible thing. We have many cases of such things like I mentioned auto throttling and all these things. Those are largely automated. And even if cases they're not automated, we have AI-enabled enrichment, which gives enough enrichment on the incident to give the person on call enough context to optimize mitigation first. In this particular case, obviously that was missed, right? So we have added enrichment with sort of which takes into certain signals that we are missing, like out of memory, certain kinds of crashes, and certain kinds of retry amplification, which is not caught in the regular traffic metrics, because the regular traffic metrics was not taking into account the fact that there were internal retries and all that. So these signals are now incorporated. Obviously, it's a we constantly learn and we constantly improve. But the platform for incorporating new signals as we learn is there, and we'll obviously, we have taken that into account.
That's cool. It's cool to understand, that our alerting is not just that something is broken, but with this enrichment also why something is broken. So to know that earlier, great.
Sid, when I think about customers who are creating these kind of AI applications, you mentioned earlier one of the attributes of Azure OpenAI is they can click global and they hand it over to you to take care of kind of resiliency, reliability. But when we have an incident like this, what are the other strategies that customers have in terms of either retry logic, back-off logic? Do regional strategies help? What can customers do to weather this type of event a little bit better?
Yeah. So a bit of a historical thing and where we are going. So in the past, what we used to release in a few regions, like ECS2, Sweden Central. So a lot of the customers are concentrated there. Now, starting from 5.5 and GPT 5.5, and even I think we're backfilling for some previous models, we're going to launch in like 30 regions or something. So what this means for customers, right? Especially for PayGo customers, what they can do is they can create multiple endpoints, and we have global quota as well now. So this kind of global outage is rare. Normally we can see regional failures, but even in this case, let's say if you are a global customer, and I'll come to data zones as well. But if you're a global customer, for example, one of the strategies you could do is have an endpoint in US, have an endpoint in Europe, and have an endpoint somewhere else, let's say. And that way you should be able to easily fail over traffic from your side. From a customer point of view, this is the most effective strategy that they could take. And even in this case, would have helped, because Sweden Central was, even though it was a multi-region outage, Sweden Central was outsizedly impacted. Let's say if you could have failed over to Japan, you would have sort of navigated this through. So that's, and even in case of data zone standard, for example, if you want to look at EU, we do launch in Sweden Central, Poland, and a bunch of other EU nations. So that's like I would encourage folks to customers to look at that as a viable option.
It's great to understand some of those options there, and like you say, customer-controlled failover or regional failover would be really helpful here. What's still one thing that really stands out to me is we don't talk about root causes on sessions like this, but there's always multiple contributing factors. When I think about the trigger event, at least in terms of the chronology here, right, this relatively small behavioral change, as Nitin was explaining to us, cascaded into something that was a very large, impactful event. What does that incident teach us about operating AI services at hyperscale and some of the unique engineering challenges that those environments create?
So first of all, I would like to acknowledge how central the AI apps have become in every customer experience. Even in the last year, the scale growth that we have seen is unprecedented, at least compared to many of the services I have worked on. So we understand the responsibility and how important it is for the customer business continuity. So among the various strategies, right, I would break it down into three things really. First thing is, absolutely reduce blast radius. We cannot have these big regions affected at this scale, and we need sharding like we discussed. So reduce blast radius. Second, early detection. That's a continuous theme for us, and that's in every incident that happens, small or big. That's the first question we ask ourselves: time to detect, and time to notify customers, and time to mitigate. So those are things we constantly want to drive down. And the third is fast automated rollback in case of change-related outages, because in this particular case was slightly different, but in general, a lot of our outages are change-related. So if we have good control on blast radius, we have early detection and early automated rollback, that is our top 3 strategies that we would invest in.
I think it's really important, particularly with fault isolation. And we know that outages are inevitable, but if we can make those impact pieces very small, it's interesting. And I think what I find really interesting as well is the rollback, because this deployment that was out, if there were no failures, the retry storm would never have occurred, and they can go dormant for a while. And so correlating the bad deployments and rolling back, I know it can be very tricky, particularly for engineers to create those links. Yeah.
I think it's interesting, like you say, the blast radius is the #1 priority here. We know that things are going to break, and so we need to break small, we need to break isolated. That's a really important piece here. You also mentioned time to notify. Now, Sammy runs our comms team. How did we do from a communications perspective? Were we able to keep customers up to date? It sounds like we had Brain and some auto alerting. Was that enough?
Yeah, so Brain is our mechanism that communicates the impacted subscriptions, typically pretty early and within 15 minutes. When we look back at this, the failures that we initially saw in Australia when the deployment hit Australia were light and degraded, and we communicated those through Brain. Said we've worked with your team for the last year, also to make sure that Azure OpenAI is onboarded to Brain. When it hit Sweden Central, Brain still did its thing, and we ended up communicating to a big chunk of customers who were impacted from around the world. And while our communications were quick, they lack detail. And we said, hey, we're doing things and we're applying mitigation and it's an us problem. And that's great for customers to realize that, yes, it's us and we're working on it. But I think what's very helpful for customers to say, we've disabled this, we've routed this, we've reverted this, we're examining this. And really one of the goals of the communications team is to bring customers into the operating theater, to bring them into the bridge without being on the bridge and let them know exactly what's going on almost real time. We try and do periodic updates. We did keep the cadence to an hour, and it's great that we keep customers updated that we're still investigating, but I think we could have done a better job in providing some of those details, which sometimes is hard to do, but I think we missed an opportunity there.
Yeah, that's a tough one. I know when I'm on call as a communications manager, if the answer is, tell them we are mitigating, tell them we are applying mitigation, the natural follow-up question, what are we doing? What are we doing to mitigate? I'd love to explain that to customers as well. So, okay, I'm glad Brain fired. At least we were quick, but maybe those updates could have been even more detailed. Thank you for watching another Azure Incident Retrospective. If this was your first time joining us, or you're interested in hearing about Azure Incident Communications generally, we're just going to run through some quick fundamentals here. Sammy and I are both from our Azure Communications team. We exist to tell our customers what's going on. We're not part of marketing. We're not part of our customer support team. We're really just a conduit between our various engineering teams involved on call during issues in explaining what's going on.
Absolutely. When we think about outages, we tend not to think about our competitors as being other cloud providers. We tend to think about our competitor in this sense being on premises, because when customers have an outage on premises, they typically know what's going on, they get updates, their leadership's involved. And so we've developed our communications philosophy in 5 areas that try and bridge that gap between on-premises and cloud. The first one is around speed. We need to tell customers quickly what's going on. The main area of this is with our AI ops. We call it Brain internally, and Brain can tell impacted customers what's going on within about 10 or 12 minutes to those impacted subscriptions. Typically speaking, we have about 70-80% coverage of our outages are onboarded into Brain, and we're constantly working to onboard more. The next one is around accuracy or granularity. It's really important that customers understand which of their resources are impacted. Telling customers that virtual machines in East US are impacted is not as helpful as telling them which of their virtual machines are impacted, and this is accessed through resource health. The third one is around discoverability. It's common practice that customers go to our public status page to look for incidents that impact them, when in reality, 99+% of the time, we speak to impacted customers through the portal in Azure Service Health. Customers are able to configure service health alerts that plug into PagerDuty, Opsgenie, and so on. The fourth one is around parity. Not only parity of our hundreds of services across Azure to ensure that they behave and respond in the same way, but parity across our Microsoft cloud. We understand how important it is to have a continuous and predictable practice across all the cloud products that Microsoft offers. And the last one is around transparency. During an outage, we try and tell our customers exactly what we know in real time. And again, you've just witnessed an Azure Incident Retrospective where we believe that the transparent approach in understanding what happened is a key ingredient for building trust. All of those principles and philosophies can be captured in Azure Service Health, where customers can understand which of their resources are impacted, get those brain alerts firing to their subscriptions, set up service health alerts, and get invites to Azure Incident Retrospectives along with post-incident reviews following an outage.
That's right. That's how we kind of think about our comms philosophy. To apply it in practice, I'll run through a quick anatomy of an outage, how you would expect to interact with communications before, during, and after an outage. So before an outage, it's really important, as Sammy mentioned, to configure that last mile delivery through Azure Service Health Alerts to tell the right people in your organization in the right way and in the right tools that make sense for them. Secondly, there's a lot of other monitoring that exists within Azure. You can configure Azure Resource Health Alerts if you want to know about every blip and pause that happens on a specific resource. We've got scheduled events to surface things within the VM, as well as a full suite of Azure Monitor to look at everything you could possibly want to observe about things that are going on with your Azure services here. We'll also touch invariably in these live stream sessions to talk about availability zones, site recovery, Chaos Studio for fault injection, storage redundancy options, all of these different features and services that you can take advantage of to build resilience into your applications and into your workloads on Azure. And lastly, beyond the specific architectural elements, we've got a bunch of guidance that's available through our docs and learn pages to talk about the cloud adoption framework to help your organization adopt the cloud, and even the well-architected framework to look specifically at individual workloads, including how you can make those more reliable. Lots of resource-specific guidance and advisor. This is just a small number of things that you can have a look at to help kind of remediate and improve your resilience gaps.
Wonderful. So now that customers have done those things before an outage, we fast forward to during an outage, what's happening. Now, myself and the team, we're interested in building systems that scale. We understand that in order for us to tell millions of customers around the world what's happening with their resources, we have to build systems that scale. And so one of the ways we do this is by investing in areas where we democratize information. And what that means is whether you spend $1 billion a year on Azure or $1 a year on Azure, we're going to tell people the same thing. We also want to tell them in the same source of truth as well, which is why we rally around single sources of truth, both internally and externally as well. In addition, during an outage, we want to tell you not only what's going on that we know and have confirmed, but at times things that we don't know. We're still ruling out a change. We're still looking at data center. Something doesn't make sense. This mitigation was attempted and failed. We want to tell our customers everything that we know so that they can make decisions and how they do this. Now, during an outage, many customers raise support tickets, and sometimes that's a great idea, and other times it's not so. It's not the best use of time. It makes sense to open a support ticket when if you've set up an Azure Site Recovery, as David mentioned, and you need help failing over, that's a great time to leverage our technical support team. If you're just raising a support ticket to confirm that the impact that you're seeing matches the symptoms that you're reading in Azure Service Health or the public Azure status page, that's not a great use of your time or the use of the time from our tech support agents as well. A lot of the time, David and I get questions around how does Microsoft respond to outages? How does Azure respond to outages? And generally speaking, we have about 3 categories. The first one is we kind of call them expected outages. We expect VMs to blip. We expect them to go down from time to time. It's not common practice. We have a multiple line SLA, but we do expect these things to happen. When this does happen, we respond appropriately. The ones that we kind of call unexpected is when we might lose an entire zone, and we might see multiple servers impacted in that zone. And typically speaking, we have a response profile for that. But really where things get unacceptable, and we kind of call it whoa, and it's a bit egregious, is when there's multi-zone or multi-region impact. This is really hard for customers to architect against. And so as a response profile to this, in addition to publishing a post-incident review within 14 days, we also try and get something out within 3 days so that customers know what we know so far. But also this is when we run the incidents like we've just had now with an Azure Incident Retrospective, so you can hear directly from our leaders what happened and navigate some of the complexity. And it's a great opportunity to ask our SMEs questions in real time about how the issue impacted your own environment and some of the steps that you can take perhaps to be resilient to those types of things.
That's right. So mileage varies depending on what kind of outage we're talking about here. We're starting to get into a little bit this after outage world. And as we pivot around to our learnings and our post-incident reviews, we really want to be quite intentional about how we learn from incidents and how we talk about that learning. That's why we try to resist the urge to talk about a root cause. We're not looking for one thing that went wrong. With massive distributed systems, we're looking for all of the different contributing factors that had to line up for customers to experience the impact they did. We want to learn from all of those. So we're not just looking for one thing. We also try to resist framing anything as human error, right? If a human or an operator made a mistake, that's a signal to us that our systems didn't provide that operator with the right intelligence, or that our systems lack the right safeguards to prevent that person from being able to cause customer impact. In a similar vein, we want to resist blaming the person at the keyboard. We know that we can't fire our way to become more reliable, and actually we want to encourage this culture of people to speak up when something bad is happening. Our engineers, and especially our leaders, need to know that we want to have a blameless retrospective and rally around trying to improve the situation as quickly as possible. We want to resist "I told you so," but as we've talked about a little bit in this session, customers have a role to play in the shared responsibility model. And so we want to use outages as a way to educate customers about decisions and trade-offs, about the different resilient services that you could use to try to have something be less impactful for you next time that it happens. We want to resist the urge to reassure customers an incident won't happen again. We always talk about what could we do to make this kind of thing less likely or less impactful, but it's inherently, it's probabilistic here. Sometimes outages look really similar, but actually involve very different failure modes. And lastly, we want to resist the urge to tell the perfect story. Our outages aren't TED Talks. They don't start with once upon a time and end with they all lived happily ever after. We actually want to embrace ambiguity and encourage everybody to have a conversation about topics that we don't have the answers for, and where we're still trying to figure out the right path forward or the right way to improve things. That's a really important part of the story. We don't want to gloss over that. So across all of these different areas, we really want to make sure that we're learning from incidents in quite an intentional way. And this is how we show up to you in the Azure Incident Retrospectives when we have these conversations with our engineering leaders. A couple of links on screen here to make sure that you have access to our previous recordings, as well as a way to get invited to future sessions. So thank you for joining us for this incident retrospective, and we hope you learned a little bit more about how incident communications works on the Azure platform. Thank you.